factoring. And there's not really much like theory or notes to take other than just some examples. Other than I would remind you to look for this one particular thing first, because it makes your life easier. It's not always there, and so people forget to look for it and end up working harder problems than they need to. If you remember to look for it, it's pretty easy to do. Does anybody have any idea what I'm talking about?
GCF.
Yeah. Always look for GCF first, because it usually makes your life easier. It's usually not hard. It's just if you forget to look for it, then you're kind of stuck spinning your wheels. So that's sort of the only background information we need to get started on some factoring problems. 6x squared minus 30x plus 24. So normally you probably are thinking, oh, we need to do that double parentheses thing. But this would be a hard one with the 6 there. What should we do first? Yeah, let's take the 6 out. The 6 can factor out. That will make our life much easier. Because the 6 is the GCF. And since we're only factoring today, we're not solving, that 6 needs to just go along for the ride. If this was equal to 0, then we could kind of throw the 6 away because it wouldn't give us any answers. But since we're just factoring today, that 6 needs to stay there. All right, how to factor one of these. People teach a gazillion different ways. Maybe you've heard of magic boxes, giant X's. It doesn't matter. They all come down to you need to multiply to that guy and add to that guy. So mostly it's just a game of guess and check, but it's not like random guessing. Like you know what multiplies to be 4. Your only options are 1 and 4 or 2 and 2. But add to negative 5, the only way we're going to get there is the 1 and 4. And then we start thinking about signs. Remember, if this is positive, they've got to be the same sign so that they multiply to be a positive. If this is negative, then that'll force them both to be negative. I hope that took me 5 times longer than it would take you. Like I hope you've done enough of these where factoring is kind of second nature. (16y squared minus 25). Okay, no GCF. Any thoughts on that one? What you got?
You take the square root out of all of them.
Okay, kind of. They are both perfect squares, so that's definitely related. Now, when you say you take the square root of both of them, like you're not going to tell me the answer is just 4y minus 5, I hope. What would you say the answer is?
You have to do it twice. Like you have to do 2 4y minus 5.
So 4y minus 5 and 4y minus 5? Right, if you did this, then you'd end up with a plus 25 here. So you're on the right track,
Yes, yeah, you do the plus.
but a plus. By the way, those are conjugates. Conjugate, the middle term will go away. And so we're kind of using that conjugate idea in reverse here. This type of factoring is called difference of squares. So when you recognize that both terms are perfect squares, you can do the plus minus thing. 27a cubed minus 64. This is one that students don't like because we don't use it very often. Do you recognize what's going on here, even if you don't remember how to do it? Okay, soap. So what do you remember what this is called? Like what are both of these things? Like those were both squares. These are both perfect cubes. And so this is a difference of cubes. So that's step one, is recognizing, okay, both of those are perfect cubes. And then the pattern of what we do with them, it's the type of factoring you don't use very often, so a lot of times you forget. The first parenthesis has 2 terms, second parenthesis has 3 terms. SOAP is part of this. Do you remember what SOAP tells you?
Same, opposite, always positive.
Okay, that's what it stands for. Same, opposite, always positive. That tells you the signs. It tells you the signs that go in there. So same meaning same as the original, and then opposite and always positive. So that's good, but that's not everything, obviously. Do you remember what's going to go in this first blank? 3a. So or even the first parentheses, you take the cube root of both pieces, and that's what goes in those 2 blanks. Most people get that far, because if you recognize that those are perfect cubes, it's because you know that was 3 cubed and 4 cubed. And then sometimes people do all sorts of things from there. They forget about SOAP. All right, in the first blank, we will square the first term. So make sure you square all of it. 9a squared. Square the first term. So 3a squared. And then I skip the middle one. I get to the end one because the end one is kind of the same thing. We're going to square the second term. So 16. And then do you remember how you get the middle term?
A times 4.
Yeah, you multiply the 2 together. So 3a times 4 would be 12a. And don't worry about pluses and minuses on any of that, because SOAP took care of the pluses and minuses. So people start thinking, wait a minute, if I multiply the 2 terms, what do I do with that negative? Don't worry about it. SOAP takes care of the signs. Why don't you try that one? 8 plus 125y cubed. I'm having you try it after we just did that one, so yes, obviously there's some similarities there. Let's see if you can follow the pattern and get that one. So there's the answer to that one. I judge based on your reaction to seeing that. You've done it before, it's just not super familiar. So you need to put that back in your brain or recall it from the recesses of your brain, because you will see that one again. X to the 4th minus 81. X to the 4th minus 81. Any thoughts on that one? It's another kind of a conjugate problem, yeah. It's a difference of squares. What would we square to get to x to the 4th? X squared and 9. So x squared plus 9 and x squared minus 9. Except that we're not done on this one. So the reason we're seeing this one is this is a multi-step problem. Because what else can we do? The x squared minus 9. So x squared plus 9 is still there, and then x plus 3, x minus 3. So not difficult, but if you hadn't seen one in a while or hadn't seen one at all. Right, this one's, I don't know, it always looks funny, but it turns out to not be so bad. Km plus 7k plus 2m plus 14. So pretty wildly different than all the others. You remember how to handle this? Have you seen one like this before? Nobody knows.
I don't remember.
Anytime there's 4 terms, we'll use grouping. Anytime there's 4 terms, we'll group them together and kind of see what happens after that. In fact, after we group them, then we'll do GCF. So it's not a greatest common factor of everything, it's a greatest common factor of the groups. So on that first group, JD, just looking at Km and 7K, what could we factor out of that? Okay. Indeed. And then what would that leave us with if we take out a K?
M plus 7.
M plus 7. Gregory, on the second set of stuff, what would our GCF be? Again, we're only looking at that second set. What could we factor out of that? A 2, and what would that leave us with? M plus 7. Well, isn't that convenient? That M plus 7 is the leftovers in both of them. If that doesn't happen, then we probably wrote the problem wrong. Because we want those leftovers to be the same. Because now you have k times something and 2 times the same something. So you can factor out the m plus 7. And when I factor out m plus 7, it leaves k plus 2. And by the way, this one reminds me that on factoring, you can always check. What would you have to do to check this problem? Yeah, distribute, FOIL, multiply. If you multiplied all that out, you should get back to where you started. Like literally no one checks checks all of them. But occasionally I'll see some on a test where someone comes out to the side and foils it to make sure, that they did that one right. Probably your least favorite. 2x squared minus 5x plus 3. Why would I say that's your least favorite? What's different about that one?
There's no GCF.
Okay, no GCF. That's part of the answer.
You put like the 2 in the
It turned 2 out there. So a isn't equal to 1. If we're thinking ax squared plus bx plus c. Factoring is just so much easier when a is 1, because then it's just multiply to 3, add to 5. But with a 2 out there, that kind of jacks things up, because now it has to be 2x and x. And whoever gets paired with the 2x is going to get multiplied by 2x rather than just an x. Switching to a pencil here. because this is now just kind of a guessing game. This is another place where there's 100 different methods, but at this point, we need you to just guess and check and get there quick. Like, that's probably the easiest way. Factors of 3 are 1 and 3, so there's only so many options here. Let's see. What about the signs? Maybe that'll help us. This is the O and I of FOIL. They still need to add to -5. And if this needs to multiply, then I know that they're both going to be minus. So my only options are 3 and 1. So let's just guess and see if it works. Again, I switched to pencil. That way I can make a mistake and fix it. So outside, that would be -6x minus 1x. That would not be it. So let's switch the 1 and the 3. That way the 1 is across from the 2. And now we've got -2x minus 3x. That equals -5x. That's what we were looking for. So the first and the last of FOIL you can sort of force to happen. It's getting that middle term from the O and the I is where the guess and check comes in. And sometimes you got to play with numbers, play with signs until it works out. But even guessing wrong a couple times is probably faster than the more methodical ways to get there. Let's do one more. 6x squared plus 7x minus 3. Again, look for GCF. It's not there. So I'm stuck. Although this one is, I've got to go to a pencil right away because I don't know if it's 6x and x. Or if it's 2x and 3x, I don't know yet. So let's try 6 and 1, and at least on the other end, there's only 1 and 3 are my only options. If I put a 3 across from the 6, like no way that's going to work because I just made 18, so that's no good. So let's switch the 1 and the 3, see if we can come up with 7. So that's now 6x and 3x. I can't get 7 out of that. So 1 and 6 are out. Let's switch to 2x and 3x and see what happens. I left the 3 and the 1. I don't know where they go, so we'll just start with how I left them. Right now I'm looking at 2x and 9x. Oh, I think I'm onto something here because I can make 7 out of that. Let's see. -3 at the end. Those need to be different signs. And I want 9 minus 2. So plus 3 would give me a 9x. Minus 1 would give me a minus 2x. And then 9 minus 2 is 7.
So you decided before you started doing FOIL thing to split 6 into 2?
Well, I tried 6 and 1, so I didn't know if it was 6 and 1 or 2 and 3. And I guessed wrong intentionally, but I guessed wrong first. All right, it's so fun when the math teacher guesses right the first time every time. Well, of course you did. You've done this 100 times. As you do these, you'll get better and you'll get a better feel for them. I would say that it's usually wise to start with sort of the inner factors rather than the extreme factors. And that goes for either end. For whatever reason, usually, not always, but usually it's the closer factors, not the extreme factors that end up working out for you. All right, today's assignment is worksheet 2. It's